Afternoon. I'm Matt Przybyciel of ES Industries, and this afternoon I'd like to go over understanding the potential of sub-2 micron HPLC columns is actually the full title of the talk, but sub-2 micron columns. And it's not only to try to make the user of the chromatography technique have a better understanding, but what we have gone into over the last couple of years ourselves at ES Industries to try to get a better understanding on how to develop this technology and utilize it in a way that can be beneficial to the chromatographer. What the sub-2 micron particles provide for for liquid chromatography, might provide something good for gas chromatography too, I don't know, is you get high resolution. Is there a laser on this? No, okay. You get high resolution. That's obviously something that's given with the smaller particles. We know that from various chromatographic equations. High speed analysis, and in a combination of high resolution and high speed analysis. So that's what the sub-2 micron really brings to the table. And one of the things that we really want to focus on is the use of the technique for high speed analysis, and we really think that's the strength of the technique, is to maintain that resolution but to really accelerate the analysis and reduce analysis time significantly. So in that area we've spent a lot of time in looking at various base particle technology for the sub-2 micron columns that we have developed. And we were looking at the particles in the sense from having high efficiency but also having a favorable back pressure characteristics, so that we could get a good compromise between high resolution and good analysis time. One of the ways you can speed up your analysis is obviously increasing your flow. As you change your flow rate, you raise your... Oh, what do we do? Just hit the wrong button there. That's it. Yeah, that's right. My fat fingers. And one of the ways to speed up the analysis is to adjust the flow rate. And this is a test mixture that we put together in looking at some of our column technologies. Just a simple 9-component test mixture, gradient analysis. Again, 1.8 micron particle is what we've settled on right now. Seems to be very favorable for good back pressure characteristics and a good analysis and good resolution characteristics. So we could start here at a flow rate of about 375 microliters per minute. This is a 2 millimeter ID column. As we crank up our flow rate, in this case we go to 600 microliters per minute, we can significantly reduce our analysis time, and we're able to keep our pressure reasonable, about 600 bar. And again, the 1.8 micron column, same column as in the previous slide. Again, if we could go up to 800 microliters, we keep our pressure under 800 bar. We reduce our analysis to 5 minutes for these components, and actually, if we were more aggressive with our gradient conditions, we could really even tighten this up more in terms of analysis time. We have a lot of space between peaks here. So the point is, we've looked at particles, we've explored it to the point where we feel we've settled on a 1.8 particle that gives us good high resolution characteristics and good back pressure characteristics. I think it's really key to utilizing this technology day in and day out. And based upon the work we've done, we've now, one of the things that ES Industries is known for is the exploitation of different stationary phases for chromatography. And once we settle on a good base particle and a good way of packing columns and presenting the columns, we went ahead and we've developed a whole series of different stationary phases so that the chromatographer is just not locked into the C8 and C18 type stationary phases, because we think the sub-2 micron technique is really the future of HPLC, and for the chromatographer to have a variety of stationary phases available is really where it needs to be. That's so that we're just not limited to the hydrocarbon stationary phases. So we have a phenyl phase, we have a SCX strong cation exchange phase, cyano, a phenyl hexyl type. This is a fluorinated octyl type. We've been involved in the development of different fluorinated phases for a while. a perfluorinated phenyl that's developed especially for use for mass spec work. It has a low bleed characteristic. Our polar phase, which is good for retaining polar compounds. A diol for Hillick mode. A fluorinated phase for Hillick, and a pi electron donor phase for Hillick, and finally a silica phase for Hillick. So that's our new complete product line of sub 2 micron HPLC columns.